So for now, we'll be looking at Chapter 1, Section 4, Validity, Truth, Soundness, Strength, and Cogency. What I should say is validity, truth, and soundness will have to do with deductive arguments, and strength and cogency and truth will have to do with inductive arguments. You've seen these before in Section 3, but now we're going to be able to test whether they're actually good arguments, not whether they're just valid or invalid, as we'll quickly see, or whether they're strong or weak. Okay? So let's go through this. Begin this. This section introduces criteria for evaluating deductive and inductive arguments. We're going to do this in a different way if you go that far, by looking at fallacies in chapters 3, and by testing for validity through Venn diagrams, and then using truth tables are the ways to test for validity or invalidity. Okay? So to evaluate either a deductive or inductive argument, we ask two questions. Do the premises support the conclusion? Are all premises true? Right? Notice that so far when we've been talking about arguments, we haven't even gotten to this. Are the premises even true? When it comes to what we're going to call validity and inductive arguments, and strength or weakness and inductive arguments, what we need to recall is that at that point you're not asking whether the premises are actually true. You're only asking whether or not, in fact, if they are true, does that lead to the conclusions of that argument? And then our second step will be for both to ask, well, actually, are the premises true if they turn out to be valid or strong arguments? Okay? So that's only the second step. So the first step is to test our deductive arguments to see whether they're valid or invalid. And the first step for inductive arguments is to test whether they're strong or weak. And remember that in deductive arguments, if the premises are true, the conclusion is necessarily true. In inductive arguments, right, if the premises are true, the conclusion is only probably true, right? And we deal with both kind of arguments every day. In inductive arguments, you say, well, every time I've seen this director in recent history, his movies have been great, therefore probably his next one will be great as well. That's an inductive argument. A deductive argument would be like, all men are mortal, Socrates is a man, therefore Socrates is a mortal, right? That is a categorical syllogism, a classical one, and that one is deductive. And so if the first two premises are true, then the conclusion is true. So in deductive arguments, if the premises support the conclusion, the argument is said to be valid. But in an invalid deductive argument, it is impossible for the premises to be true and the conclusion to be false. That is the key. If, though, the premises are true, the conclusion must be true. That's what we're asking when we're talking about valid deductive arguments. We're not asking whether the argument is sound yet. A sound argument will be a valid argument that actually has true premises. Right now we're saying, if the premises are true, does it necessarily support the conclusion? So for an example, all dogs are mammals, all mammals are animals, and all dogs are animals. Now here we have a direct link, which you should always look for in categorical syllogisms, between where these two terms are the same. You can then, and there's an are and all involved, you can then just go, all dogs are animals, and then you should see that as the conclusion. And that is a valid categorical syllogism. Right? And you can see that here we have a line that separates premise 1, premise 2 from premise 3. For now, we don't care whether these are true. Right? That sounds odd, but we will get there. We will get to be asking if the premises are true, and therefore whether we have sound arguments. Right? So the argument is, of course, valid. The conclusion follows necessarily from the premises. Right? It can't be true that these are true and then this turns out to be false. Right? So it's a valid deductive argument. All dogs are snakes. All snakes are dogs. All dogs are birds. Right? The premises support the conclusion just as in the previous argument. If you assume the premises are true, it is impossible for the conclusion to be false. So that's the strange part of looking at validity. We're not asking whether all dogs are snakes, right? And we're not asking whether all snakes are birds. We're asking after the form of the argument, right? And because the form works, and because the reasoning works, then it is a valid argument. I'm not saying this is not an argument about whether the argument is good. It's not saying this is an argument one should make. I'm only saying it's a valid argumentative form. Later, we'll ask whether it is a sound argument. And there, the truth of the premises will come in. All dogs are not, in fact, snakes, and all snakes are not, in fact, birds. But that has nothing to do with its validity. The form of the argument, the form of the reasoning, is what we are after here. Right? That is, if you assume that the dogs are in the snakes group and the snakes are in the birds group, then, and you'll see this a lot, these circles in the next few minutes, then it is necessarily the case that all dogs are birds, right? But again, this is not necessarily true or a sound argument, but it is a valid one. So there's no uniform relationship between truth and validity. That is not a question we're asking right now. We're saying if the premises are true, then does the conclusion necessarily follow? Okay? So valid arguments can have true premises and a true conclusion. Valid arguments can have false premises and a false conclusion. And something we won't take up yet today, they can actually have false premises and a true conclusion. Okay? But valid arguments, if the premises are true, they have to have a true conclusion. That is our focus for today. For other chapters, we'll focus more on these two. But if they have true premises, they must lead to a true conclusion. So in deductive arguments, one arrangement is not possible for a valid argument. You cannot have true premises and false conclusions. That's our focus today. True premises must lead to a true conclusion. If they do not, then the argument is invalid. Okay? So for example, all dogs are animals, all cats are animals. Does that really mean that all dogs are cats? Right? Now this sounds very confusing, but again, we use deductive reasoning all the time, and here we are just breaking it down into simple, not as simple as it looks, of course. I'm not suggesting that at all, but that all dogs are animals, all cats are animals. Is it in fact the case that all dogs are cats? No. Right? If all dogs are animals and all cats are animals, that doesn't mean that all dogs are cats. Right? Obviously in real life that's not the case, but it's actually the argumentative form that we're looking at. Right? If this is true and all dogs are animals and all cats are animals, well, we can imagine them in two different circles. We can imagine a circle, I'm kind of drawing it here, that is all animals, and dogs are here and cats are here, right? And that means that there are all kinds of animals that are not dogs or cats, right? And so therefore, dogs do not necessarily need to be in the cat category, right? That's what makes this argumentative form invalid, right? The premises are actually true, yet the conclusion is false, right? So in deductive arguments, if you get a true premise, you can even have 15 premises that are all true, but if they lead to a false conclusion, then it is invalid. If they do not necessarily lead to a true conclusion, then they are invalid. It's not necessary premises be actually true and the conclusion actually false for the argument to be invalid. If it is merely possible for the premises to be true and for the conclusion false. The argument is invalid. What I mean by that is simply this. In deductive arguments, we're looking for certainty. And so all you're looking to ask is, if this premise 1 is true, if premise 2 is true, does it lead you to does it necessarily follow that the conclusion is true? Right? Again, we're asking if it's the case. Okay? And if it's not, if the conclusion does not necessarily follow from the premises, then it is an invalid argument. So an example, this is an invalid argument. All dogs are animals, all mammals are animals, therefore all dogs are mammals. Now it is certainly the case that all dogs are animals, right? But we're asking if all dogs are animals and if all mammals are animals, right? This doesn't tell us, we can imagine those circles again, all animals, but we can imagine dogs are over here and mammals are over here, and therefore all dogs would not be in that mammal circle. Now we know in real life all dogs are in fact mammals, but it's the argumentative form that we're looking at, okay? So in this argument, all statements are true in the real world, but it is possible for the premises to be true and the conclusion false. All statements are true, but again, that's not what we're looking at when we're looking at validity and invalidity. We're looking at the argumentative form. If this is true and this is true, is this necessarily true? Unfortunately, it's not, so it is invalid. So all dogs are animals, all mammals are animals, all dogs are mammals. And see, this is the circle that I was trying to represent before, right? That is, we can imagine that there are all these animals, and dogs can be arranged here away from mammals according to this argument. And so because that's the case, it is not a valid deductive argument. It is possible for the premises to be true, but for the conclusion to be false. Again, we're not at step 2 yet. Step 1 is the argumentative form valid? And then in step 2, we're going to ask, are the premises actually true? Right? If we have a valid argument, are the premises actually true? Then we have a sound argument, because then the conclusion will be necessarily true. And that's what the gold standard is to have a valid and sound argument. Right? So validity is determined by the relationship between the premises and the conclusion. That is, if premise 1 is true, if premise 2 is true, would it lead you to premise 3? If it does not, then it is not a valid argument. A valid argument reflects a good reasoning process, and an invalid argument reflects a bad reasoning process. We will learn different ways later for finding out validity and invalidity using Venn diagrams and truth diagrams. But for now, we're just trying to go over the distinction between valid and invalid, and then soundness and unsoundness when it comes to deductive arguments. Okay? So let's now practice what we've learned. All salmon are fish. All fish are animals. All salmon are animals. Well, again, look at the middle term. They are all together. We have all and all. So all salmon are fish. All fish are animals. Is it necessarily the case that all salmon are animals? Forget what you know about the fish world and what you know about animals. For right now, we're just looking at the argumentative form. Is it valid or invalid? Indeed, it is a valid one. If you assume, again, if it's the case, if you assume, right, just as in the circle, that all salmon are fish, that's what the first premise is saying, and all fish are animals, as the second premise is saying, then all salmon are animals, right? It goes out in concentric circles. That's what we'll be talking about, right? So now let's look at this one. All salmon are fish. All salmon are animals. Therefore, right, conclusion, all fish are animals. Another deductive argument. Is this argument valid or invalid? Well, again, those circles are not going to line up. They're going to be like the dog circle before. I wish I could draw on this screen like this. But you'll have a big circle where there are, so we can look at all salmon are fish, then all salmon are also animals, and then, but does that tell us anything about fish? Well, we can imagine fish that are not animals. It just happens that all salmon are the fish type animals. So it is an invalid argument. Right? If the salmon are inside the animals group and the animals are inside the fish group, then the premises would be true, but the conclusion would be false. All fish are not animals. In fact, that's the broadest category given to us. Okay? So it is an invalid argument. Right? You can't have true premises, two true premises, and a false conclusion. Right? So is this argument valid or invalid? All animals are birds. All birds are robins. All robins are animals. Is this argument valid or invalid? Okay, let's just take this to be, let's look at this. All animals are birds. Okay? All birds are robins. Now we have a separation. Look at this. We have this linkage. So we can know then, we can read all animals are robins and drop right down. Right? But does that mean that all robins are animals? No. Does this tell us anything about robins? We know that all birds fit in the robin circle, but we don't know that they fit all in the animal circle. Right? So again, this is about reasoning. Right? Which can be very difficult. Right? But this is where it's good to break out a pen and paper and to draw out the circles. Right? Draw out the circle where you say all animals are birds. Okay, so you start with animals and they fit in the bird circle. Okay, and then you say all birds are robins. Okay, so then you put, where do I put the birds or robins? And then all robins, do they all fit in the animals? No, because the broadest category, of course, is birds. The birds would be the farthest one out. So it is an invalid argument, right? Robins turn out to be the largest circle here. Okay, both premises are actually false. But if you assume they are true, again, validity, we are just assuming for the moment they are true. Then the animals would have to be inside the robin group. The valid conclusion is all animals are robins. So all robins are crows, all crows are birds, all robins are birds. Okay. Now, leaving aside what we know from the real world, we're testing for validity and invalidity. Right? Now, again, we have what we look for in categorical syllogisms, right? We have this commonality, and we have the words all, like all men are, Socrates is a man, all men are mortal, Socrates therefore is immortal, right? This is all robins are crows, all crows are birds. Now, if these are both true, does this necessarily follow? Indeed, it does, right? You put the circles in. All robins are crows, all crows are birds. Okay, and it is a valid argument. Now, we have not yet asked whether it is a sound argument. That is, are the premises actually true? We're only saying if they are true, they lead to this conclusion. I know that can be very confusing, and it seems strange that we would be talking about arguments which we take to be very seriously, take very seriously in philosophy, and which we take very seriously when we're making arguments inductively or deductively, whether we're scientists or business people and so on, right? We make arguments all the time. So it might seem strange that when we begin to talk about arguments, we leave aside the real world. But in terms of the logic that we're learning here, when we're just testing for whether an argument is valid or invalid, all that matters for now is if robins are crows, they're not. If all crows are birds, then it necessarily follows that all robins are birds, right? So it's a valid argument. So let's go here. Some robins are birds, some birds are hawks, some robins are hawks. Okay, so note in logic, we're going to get to this later at some more depth, but here some means at least one, right? So is at least one robin a bird? At least one, this is saying if at least one robin is a bird, and if at least one bird is a hawk, does this mean at least one robin is a hawk? No, this does not necessarily follow. Right? The premises are actually true, but the conclusion is actually false. Any such argument is invalid. Right? It could be the case that this is, if this is true, and if this is true, this does not mean that this is true. And so we haven't even gotten to the question of whether some robins are hawks, which is a false claim. We haven't even gotten to the facts that whether or not it's true that some birds are hawks, right? These premises, we haven't asked about their actual truthness. It's right now invalid, and that's all that matters. Some robins are mammals. All mammals are animals. Therefore, some robins are animals. Well, we have that form again, which we like for some categorical syllogisms, where we have a match on between the predicate of one, right, and the antecedent of the other. And so we have some robins are animals. Some robins are animals. Is this argument valid or invalid? It's valid. The first premise, of course, is false, but we're not worried about that. But we know that some robins are mammals, which means that some robins are animals. Okay, and that's all that matters for now. But we now turn to the second major question when it comes to deductive arguments. Are the premises actually true? If the argument is valid and all the premises are true, the argument is said to be sound. Okay? This is extremely important. Okay? So for example, all cats are mammals, all mammals are animals, therefore all cats are animals. Now we saw this before. Okay? That this is a valid argument. Right? But now we ask, is premise one actually true in the real world? All cats are mammals. Yes, indeed, all cats are mammals. Are all mammals animals? Yes, there are no mammals that are not animals. Therefore, it necessarily follows that all cats are animals. So we have a valid argument, and we have true premises. All of them have to be true. If even one is false, it is not a sound argument. So that's how we test for soundness. So this you want to concentrate on and perhaps even write down. If something, and it's in your book, of course, if something is sound, if it's valid, and all the premises are true. So an unsound argument is automatically one. An argument is unsound if it's invalid. As soon as an argument is invalid, it's unsound. You can stop right away. Okay, if I'm asking if the argument is sound or not sound, if you find that it's invalid, you don't need to go to step 2. But if you find that it is valid, then you have to go to step 2, which is to ask if one or more of the premises are actually false. All right? So, all cats are mammals, all cats are animals, all mammals are animals. Now, we saw before that this is an invalid deductive argument. That just because if all cats are mammals, if all cats are animals, does that mean necessarily that all mammals are animals? No, indeed not. Okay? And so it is an unsound argument because it's invalid. So we go to step 1, we've already failed there, it's unsound. So, all cats are birds, all birds are animals. Does that mean that all cats are animals? Now, we have what we like when we're looking for validity in categorical syllogisms. All cats are birds, right? And we see the link here. All birds are animals, good. And so we can read right across. All cats are animals, all cats are animals, good. It is a valid argument. But now, let's ask the second question. Are the premises true? Are all cats birds? No. As soon as you find one premise that is false, you have an unsound argument. A sound argument is perfectly good deductive argument. It has true premises, it has good reasoning, and therefore it has a true conclusion. So to evaluate, again, to repeat, an argument for soundness, first we check for validity. Then, and only then if it's valid, do we check to see if all the premises are true. Okay, so let's do some practice problems here. All rabbits are mammals. All mammals are animals. Therefore, all rabbits are animals. Again, for categorical syllogisms, when you're doing your homework and when you're looking at the exams, you want this nice link for when it's all, right? And so we see here the match, so we can read right across, all rabbits are animals. All rabbits are animals. That is our conclusion, indeed. This is a valid argument. Right? And this encapsulates it nicely in terms of these circles. Okay? Is this sound or unsound? Are all rabbits mammals? Yes. Are all mammals animals? Yes. Therefore, are all rabbits are animals? Indeed. It is a sound argument. Okay? That is because it's valid and the premises are true. Do not worry for now whether the conclusion is actually true. What you're looking for is whether it's valid and then the premises are true. So for now, for example, let's look at this. Again, we block it out for now, whether we're looking at soundness or unsoundness or validity or invalidity, whether the conclusion is actually true. All tuna are mammals. Okay? All mammals are animals, right? And now we have that nice match again, right? Of a categorical syllogism, right? We have this, so then we could read it straight across. All tuna are, boom, drop down, animals. All tuna are animals. That's our conclusion. Is this valid or invalid? It is indeed valid, right? It fits. All tuna are mammals. Therefore, all tuna fit in the animal group. Okay? But is this argument sound or unsound? Well, let's go to premise 1. All tuna are mammals. Is that true? No. Tuna are not mammals. It is an unsound premise. Sorry, it is a false premise and therefore an unsound argument. All rabbits are mammals. All rabbits are animals. Therefore, all mammals are animals. Is this a valid or invalid argument? Okay, so let's start with all rabbits are mammals. Okay? But what we don't have is that match like that we wanted. We've seen this before, right? This was an invalid argument. Okay? All rabbits are mammals. All rabbits are animals. But it doesn't tell us anything about mammals in general, that all mammals would be animals. Okay? All we know are about rabbits. This is what is being told us for us, that they happen to be mammals and they happen to be animals. But it doesn't tell us deductively what mammals are. So it is an invalid argument. Okay? It might just be the case that it's like this, that mammals is actually the larger group than animals. Now again, we're only asking if it's the case, and this is the argumentative form. It's an invalid one. That means, therefore, it's automatically unsound. You can stop right there, right? If it's invalid, it is automatically unsound. I don't need to look at whether the premises are true. All mammals are rabbits. All rabbits are animals. Good, we have this, right? And therefore, all mammals are animals. Is this valid or invalid? Well, if we look and read across again, all mammals and drop down are rabbits, right? We like that nice crossover in categorical syllogisms. Does it follow that all mammals are animals? Indeed does. If this is the case, and if this is true, this must be true. It is a valid argument. Okay? And you can see this with the circles. If all mammals are rabbits, then all rabbits are animals. Therefore, it must be the case that all mammals are animals, right? But now we go to the second test. Is it the case that all mammals are rabbits, all rabbits are animals? Is it sound or unsound? Are the premises true? Right? Is it true that all mammals are rabbits? No. We have many mammals, like whales, for example, that are not rabbits. Therefore, with one premise untrue, you can kick it out already. You don't need to go any further. You don't need to ask about whether all rabbits are animals, right? We're done. One false premise, it's unsound, okay? So the argument is unsound. It is a valid but unsound argument. So all mammals are animals. Let's do another problem. All whales are mammals. Therefore, all whales are animals. Now, here, this may, in some sense, throw you off. If you take this second premise and move this up, you would have all whales are mammals, and then you would see that you'd have that nice crossover. We have that nice crossover here. All mammals are animals, all whales are mammals, therefore all whales are animals. Okay? So in other words, in those concentric circles, all whales are mammals, right? So all whales would be in the all animal circle. In the mammals, all whales are in the mammal circle. All mammals are in the animal circle. And then the conclusion would be all whales, the smallest circle, is in the animal circle. Is this valid or invalid? This is a valid argument form. Okay? In other words, if you put the premise first, you would get that nice crossover that we usually get. But you can also just simply do it with a simple pencil, and paper, if anybody uses that anymore, and draw out the circles, and you would see that this is a perfectly valid argument. Okay? Now, is this argument sound or unsound? So step one, is it valid or invalid? We got past that. Good. It's valid. It's a valid argument form. Now, are the premises true? Are all mammals are animals? Yes, indeed. And are all whales mammals? Yes, indeed. All whales are indeed mammals. And so it is a sound argument. Right? And so now we have the gold standard. Right? That we have a valid argument, and we have true premises, therefore a true conclusion. So some tuna are fish, all fish are animals, therefore all tuna are animals. So let's look. We have this nice crossover here. Some tuna are animals. Does this tell us that all tuna are animals? No. Some tuna, at least one, is a fish, but it could be that there's some alien creature or something. We don't know. We're not looking at the outside world. We're only looking at the argumentative form. And so it is an invalid argument. Okay? And so what does that mean about it being sound or unsound? Well, it was invalid, therefore it's simply unsound. Right? And so you don't need to go further. It's true that at least some, which would mean all tuna are fish, and all tuna are fish, all fish are animals, and all tuna are animals. But the argumentative form is invalid, so you don't even get to this step. Okay? It is an unsound argument. So let's now consider inductive arguments. It's going to be analogous to the previous kind of arguments. That is, we're going to look at whether the premises support the conclusion, and the second step is going to be whether the premises are true. If the premises support the conclusion, an inductive argument is said to be strong. So whereas before we were saying valid or invalid as step one in deductive arguments, before we went to step two, whether they are true or false, and therefore sound or unsound, we are now going to ask whether the inductive argument is strong or weak. If it's weak, we stop right there, and we automatically don't have what's called a cogent argument. But if the argumentative structure is strong, then we say, are the premises true? And then we get what's called, in inductive arguments, a cogent argument. Okay, so the language is slightly different, but the work is analogous. It's a two-step process. There's an extra slight step in inductive arguments, but we'll take that up at another time. If the premises are assumed to be true, then based on that assumption, it is probable that the conclusion is true. That's what we're looking for if we're asking if an inductive argument, that is a probabilistic argument, is strong or weak. So for example, all previously discovered emeralds have been green, therefore probably the next emerald to be discovered will be green. So let's look at this premise. If it is the case, remember we're still asking, first step, if it's true, is this probable? Indeed it is, and so it's strong. It's just as in all previous days the sun has risen, Therefore, it's probably the case that tomorrow the sun will rise again. Okay? That is a strong inductive argument. Okay? But notice the probably there, right? We saw this in 1.3. Probably denotes induction. It's not necessarily the case that the next emerald to be found will be green. It's just probably, highly probably the case, but nevertheless only probably. Now, unlike validity, where something is simply valid or invalid, inductive arguments are stronger or weaker, right? So any argument whose conclusion follows with more than 50% probability is considered strong. Those that are not meeting the 50% threshold are weaker. But you could see that the higher you get in percentage, the stronger it's going to be, and the lower in percentage, the weaker the inductive argument is going to be. Okay, that's why they say there's degrees of strength. You want to get much higher than 50%. But sometimes we don't get there. And so we're just looking for what is probable. Okay, what is probably the case? It's better than a flip of the coin, right? Which just gives you heads or tails, 50% probability. So for example, few if any emeralds contain arsenic. This stone is an emerald, therefore probably contains arsenic. Well, we've been told, and I think you intuitively would get this, that if few emeralds contain arsenic, then the one that you have in your hand is unlikely to contain arsenic. It's a weak inductive argument. Okay? So we can stop there. It's already not a cogent argument, as we'll get to later. All previously discovered emeralds have been pink. Therefore, again, we're not asking about the truth of this. We're only at step one, whether it is strong or weak inductive argument. Next, we'll get to see whether it's cogent or non-cogent, just as we asked with deductive arguments, whether it was valid or invalid before we even got to asking, are the premises actually true? So if it's the case that all previously discovered emeralds have been pink, is it probably the case that the next emerald to be discovered will be pink? Indeed, yes. If we assume that, it is a strong inductive argument. Strength is determined by the relationship, as in deductive arguments, between the premises and conclusion, not strength, but their validity and invalidity, not by the truth, whether the premises are true or false. Okay, so for example, only a few previously discovered emeralds have been green, therefore probably the next emerald to be discovered will be green. That's weak, right? It's few previously have been discovered to be green. Well, why would that tell us probably the next one would be green? No, we've been told that it's unlikely to be the case. That is a weak inductive argument. So even though the conclusion, again, don't look at whether the conclusion is true when you're asking about validity or invalidity, and don't look at the conclusion if you're asking if an argument is inductive argument is strong or weak. Even though the conclusion is probably true, the premise does not provide that support. It makes it a weak inductive argument. So for example, all previously discovered emeralds have been green, but rubies are gemstones just like emeralds. Therefore, and we skipped right past that. Can I get back there? Only a few discovered have been green. Therefore, the next emerald we discovered will be green. Then we'll get to here. All previously discovered emeralds have been green, but rubies are gemstones just like emerald. Therefore, probably the next ruby we discovered will be green. That is a weak argument by analogy. So the premises must not overlook some crucial evidence that undermines the stated premise and requires a different conclusion. That is, that even though there are two gemstones, not all gemstones have the same color. This is called the total evidence requirement. Okay, so let me go back to that slowly. The last part said, just because, this is green, this has a certain color, therefore it's probable that all gemstones have this color. Well, we're leaving out extra evidence that would be important, which is that gemstones are known for having different colors. So let's go through some practice problems. All previously discovered rubies have been red, therefore probably the next ruby discovered will be red. Is this argument strong or weak? Well, all previously discovered rubies have been red, therefore probably the next one to be discovered is red. Yes, indeed, that is strong. 60% of all rubies contain chromium. This stone is a ruby, therefore probably contains chromium. Is this argument strong or weak? Remember, the threshold was 50%, and 60% is higher than 50%. You don't need to know a lot of math to know that. So therefore, this is a strong argument. It's not the strongest argument, but it is strong and not weak. Okay? Anything more than 50% is considered strong for us. Only 10%, on the other hand, of all sapphires contain calcium. This stone is a sapphire. They're probably, therefore probably, and remember, this term tells us it's an inductive argument. It contains calcium. Is this argument strong or weak? Well, it's only 10%. That's quite weak. It's a 90% probability that, in fact, it doesn't contain calcium. 80% of all sapphires contain bubblegum. If this is the case, remember we're only at step 1 here, this stone is a sapphire, therefore probably it contains bubblegum. Again, if 80% of all sapphires contain bubblegum, is it probably the case that this sapphire contains bubblegum? Indeed, it's a strong argument. We're at step 1, we're not asking whether the premises are true. We're saying if they are true, do they lead us to the conclusion that's given? And indeed, this is a strong argument. The premise is indeed false. We know that. We'll deal with that at step 2. All previously discovered rubies have been red. They're probably the next emerald to be discovered will be green. Is this argument strong or weak? It is weak. Why? Because whether rubies have been red has nothing to do and is irrelevant to the conclusion, because then we start talking about emeralds being green. Okay? So there's no relationship between these two. So that's why it is a weak argument. Okay? The premise is irrelevant to the conclusion, so the argument is weak. Section 1.4. The second question, though, just as in deductive arguments, are the premises true? A strong inductive argument that has true premises and meets the total evidence requirement, that is, have we left anything out, is said to be cogent. So, for example, all previously discovered emeralds have been green, therefore probably the next emerald to be discovered will be green. We know that this is a strong argument, and therefore now we ask, is this true? Have all previously discovered emeralds been green? Yes, that is the case. Therefore, probably the next emerald to be discovered will be green. It is a cogent argument. So just as we move from validity to soundness in our last in deductive arguments, here we're moving from strength or weakness to cogency or non-cogency here. And this is a cogent argument. And again, just as in deductive arguments, sound arguments are our gold standard. We want to get through the 2 steps. There's an extra half step to ask if we've left out evidence. We'll get to that. But for now, we know that this is a cogent argument. So cogent, you want to write this formula down, means that the argument is strong, step 1, and that we looked at the premises and they happen to be true. There's the next half kind of step, which asks us, did we leave something out? Is there something important in this inductive argument where we left something out? We'll come to this. But for now, just concentrate on this part of it, okay? That is, have we left out important evidence that would lead us to a different conclusion? So an uncogent argument, automatically, if an argument is weak, it's uncogent, automatically, just as an invalid argument is automatically unsound. Secondly, we just need to find one or more false premises. Just one, and it's out. Then we have to ask, have we left out important evidence? We'll get to this, but for now, again, is it weak? Step 1. Then step 2, we already know it's non-cogent or uncogent. Just as in deductive arguments, if we know it's invalid, it's automatically unsound. Then we ask, are the premises actually true? And we find that at least one premise, and it could be 15 premises, we've only been dealing with 2 premises at most here. If we have 15 premises and one is false, then we have a non-cogent or uncogent argument. Okay? So this argument is uncogent because it is weak, right? Only a few rubies contain calcium, right? A few. The stone is a ruby, therefore Probably it contains calcium. Well, we heard only a few of them have calcium. So therefore, it is not probable that it contains calcium. So because it is a weak argument, it is automatically uncogent. So this argument is uncogent because it has a false premise. So it may have met step 1, but it's going to meet, not meet step 2. So let's see if it's a strong or weak argument. All previously discovered rubies have been yellow. Therefore, probably the next ruby to be discovered will be yellow. Okay? That is a strong argument. If it's the case all previously discovered rubies have been yellow, it would be probable that the next ruby we would find under a rock would be yellow. But it's not cogent or uncogent. Why? Because we just need to look at the premise and say, is that true? All previously discovered rubies have been yellow? No, that's not the case. The premise is false, and therefore the argument is non-cogent. It is a strong inductive argument, but a non-cogent or uncogent one, right? And therefore is not a good argument, right? So a cogent argument is a perfectly good inductive argument. It has true premises. Nothing is overlooked. That's important. We'll get to this. Good reasoning is used, and there it gives us a probably true conclusion. Remember, in inductive argument, we're just looking for probability, right? That something probably is the case. So let's do some practice. Right? 2 things that we're going to need to know, by the way, for these examples. Most emeralds contain chromium, and only a few garnets contain iron. It turns out that this is taken for granted, and so there's no test on this when we get to it. So most rubies contain cheddar cheese. So not chromium, but cheddar cheese. This stone is a ruby, therefore probably contains cheddar cheese. Now look at the form of the argument. If it's the case, again, we're asking for whether it's strong or weak, that most rubies contain cheddar cheese, which makes them sound tasty. This stone is a ruby, therefore probably contains cheddar cheese. Is this argument strong or weak? Well, it's strong. Why? Because if most rubies contain cheddar cheese, then it would probably be the case that this ruby would contain cheddar cheese. Okay? Okay, but that's only step 1. We haven't asked whether the premise is itself true. Okay, it's a 2-step process. Is this argument cogent or uncogent? Well, here now we ask, is the premise true? Right? Remember, they're setting off nicely for you the conclusions, the therefore, right? That is, we learned that in 1.1. This is a conclusion indicator. Most rubies contain cheddar cheese. This stone is a ruby, therefore probably it contains cheddar cheese. Is this argument cogent or uncogent? It's uncogent. You need just one false premise, and you have an uncogent argument, no matter how strong the inductive argument is. It could be very strong, right? And it is strong, most rubies. But it's uncogent because most rubies do not, in fact, contain cheddar cheese. Not to ruin it for you. All previously discovered rubies have been red. They're probably the next ruby to be discovered will be red. We've seen this before. Again, it's probably, so it's an inductive argument. All previously ones have been red. Therefore, it is likely the case that if we find a ruby lying around, if we're so lucky, that the next ruby to be discovered will be red. It's probably the case. So is this argument strong or weak? It is strong, right? Now we ask whether it's cogent or uncogent. And this is where we look at the premise, right? The therefore tells us this is the conclusion, and we say, are all previously discovered rubies red? Indeed, that is the case. As far as I know, I'm not a gemologist, but as far as I know, this is a true premise, therefore it is a cogent argument. Right? The premise is true. The argumentative structure is strong, and therefore it is a cogent argument. Only a few garnets contain iron. This stone is a garnet, therefore probably contains iron. Is this argument strong or weak? Well, in fact, if only a few contain iron, then it's probably not the case that this stone that we have in our hand has iron, right? Just as if a previous musician has only put out cruddy music, it's not likely to be the case that their next piece of next album, if those exist anymore, or whatever they push out on iTunes, is going to be good, right? It's not probable, right? So if we try to suggest, hey, this musician has given us cruddy music for years, but it's probably the case the next one will be strong, will be a great album. No, that is a weak argument, okay? If you assume the premises are true, then based on that assumption, the conclusion is not probably true. Only few garnets contain iron. This stone is a garnet, therefore probably it contains iron. Well, we've already seen it's a weak argument, therefore we don't need to go any further. We don't have to ask whether these are true or not. We just say that they're uncogent, right? Once we know the argument is weak, step 2, uncogent. Done. So here's another practice problem. 30% of all sapphires contain honey. This stone is a sapphire, therefore probably it contains honey. Is this argument strong or weak? Well, we were looking for the 50% threshold. Let's forget about the attempt at humor here, not by me, that all sapphires contain honey. It's below that, so we already know it's a weak argument. It doesn't tell us that anything about sapphires probably containing honey. Okay, it is a weak argument. It's below 50%. So therefore, we already know it's non-cogent or uncogent. So is this argument cogent or uncogent? Well, it's uncogent already. We don't even need to ask whether all 30% of all sapphires contain honey, which is in fact false. That would be step 2, but we already know that the argument itself is already weak, so it's uncogent. Don't bother asking after step 2 if step 1 has shown you that it's weak. It's already uncogent. So most emeralds contain chromium. This stone is an emerald, therefore probably it contains chromium. Is this argument strong or weak? Most emeralds contain chromium. This stone is an emerald. Yeah, then therefore it probably does contain chromium, right? It's saying most of them do, right? Most albums put out by my favorite musician have been great, therefore I will probably like the next one, right? If I said, right, that's the opposite of the last, that is a good relative prediction, right? So it's a strong inductive argument, okay? Now, is this argument cogent or uncogent? Well, we learned at the beginning of the exercises that most emeralds do contain chromium. That is a true premise, and so we have that it's a strong inductive argument. We now know that the premise is true. Nothing has been left out that's relevant. That is, we don't need to know anything about within the conclusion except for the fact that most emeralds contain chromium. So therefore, this is a cogent argument. Okay. All previously discovered rubies have been red. Therefore, probably the next sapphire to be discovered will be blue. Is this argument strong or weak? No. This is irrelevant to this conclusion, right? The premise says nothing. Just because all rubies have been red tells us nothing about sapphire, okay? This is a weak argument, which means it's not going to be cogent. We don't even have to ask, even though all previously rubies have been red, because it was weak, it's going to be uncogent, okay? All weak inductive arguments are uncogent. Only a few garnets contain iron. This stone is a garnet, therefore probably does not contain iron. Is this argument strong or weak? Yes, this flips it, right? It does not probably contain iron. This is a strong argument, right? If only a few do, then probably the one you have in your hand doesn't have it. It's not one of those the special ones that contain iron. So this is a strong argument, right? Now we need to know whether it's cogent or non-cogent, and we were told at the beginning that only a few garnets do in fact contain iron. This is a true premise, and so therefore it's cogent. I'm leaving aside, by the way, the second premise, which this stone is a garnet. That's been a premise that I've been leaving aside. This stone is a ruby, and so on. I'm taking for granted that in your hand is a garnet, or you're pointing to one, or pointing to a ruby. Right? These are actually two premises. But is this true? Yes. We'll take it for granted that one is in your hand, and this is a cogent argument, right? The argument is strong, as we've seen, and both premises are true, so the argument is cogent. Okay, so section 1.4, let's summarize. Deductive arguments can be valid or invalid. Any that are invalid are unsound. And then valid arguments can be sound or unsound. Inductive arguments can be strong or they can be weak. If they're weak, they're automatically uncogent. And if they're strong, though, they can be cogent or uncogent. And so the gold standard for each is to look for, with deductive arguments, sound, valid, then sound arguments, which means they're valid and then they have true premises. And then strong means we're looking for them to be strong, that is, to have premises that lead to a probable conclusion. And then for them to be cogent, we look at the premises and we ask whether they're indeed true. And so that's the summary for section 1.4.